kick us off, the team that's been working with the New York State Office of General Services, Division of Resiliency and Sustainability under Thomas Abdallah will begin.
Hello everyone, I'm Nandita Upada, and today I'm going to present about the market analysis of low embodied carbon construction materials. I'll first introduce my team and talk a bit about why infrastructure matters, our client, the project objective, methodology, explain a bit about embodied carbon, our analysis outcomes, and end it with policy recommendations. Let me introduce my incredible team. Thomas Abdallah is our faculty advisor. Thai is our project manager. Ria is our deputy project manager. Zinni is our concrete and glass lead. Jack is our steel and asphalt lead. TC is our timber lead. Anne is our financial projections lead. Isabel is our concrete lead. And Amy is our timber projections lead. When we talk about a city, the first thing that comes into our mind is the incredible infrastructure that the city can offer. For example, in New York, it would be the Brooklyn Bridge, the Empire State Building, or the Statue of Liberty. And what lies behind this incredible infrastructure is not just the Hudson River, but also the unwanted emissions. That being said, they contribute up to 37% of the global emissions, with 11% contributed to embodied emissions. And in New York State itself, they're up to 1/3 of the emissions. With that being said, New York State has set ambitious climate goals under the Climate Leadership and Community Protection Act, where it has to reduce these emissions up to 40% by 2030 and by 85% up to 2050. In comparison with the 1990 levels. And to achieve these, it has set mandates like New York City Local Law 97, New York State Executive Order 22 and 23 to reduce embodied and operational emissions. Our client, New York State Office of General Services, works towards reducing these emissions by enforcing the embodied carbon rules like Executive Order 22 and by developing decarbonization roadmaps and by reviewing the green procurement costs of New York State multi-billion-dollar projects. These mandates require the embodied emissions to be reduced across construction materials like concrete, steel, glass, asphalt, and timber. So our goal for this project is to investigate the current markets of these materials and their relevant sustainable alternatives and project the prices up to 2050, and also to recommend the policies and strategies to improve their adoption. But the current challenges in this industry is the lack of standardization and the lack of transparency. Our methodology includes desktop research, where we have studied about the markets of the existing materials and the sustainable alternatives of these materials. And we have conducted the SWOT analysis across the levers of technical, market, policy, and economic functions. And we projected the price scenarios with respect to shared socioeconomic pathways 1, 2, and 5. 1 being the most sustainable and renewable energy-based pathway, 2 being the current state, which is business as usual with limited policies, and 5 being the most fossil fuel-based development, which has no concern for sustainability. We have conducted up to 20 interviews to get the industry expert insights. And we have interviewed companies like Witro, AECOM, and organizations like Metropolitan Transportation Authority, National Gas Associations, etc. And with these analyses, we have further developed the recommendations across the categories of education, incentivization, and regulations. Let me explain a bit about embodied carbon. Embodied carbon are the emissions that are in the production, construction stage, and also the disposal stage. Basically everything other than the operational stage. Our analysis showcases that these materials left unchecked can lead up to emissions that are 3 times higher than what it is right now by 2050. Concrete is the most used material on the planet after water. And we have studied the sustainable cementitious alternatives of cement, which contributes to the most emissions in the concrete, which concrete is made out of cement and aggregates. Currently, fly ash is the most sustainable alternative that is being used, but fly ash, there will be reduction in its availability because of the retirement of the coal plants in the US. Hence, we recommended other alternatives like glass pozzolans and GGBFS. Glass porcelain is made out of recycled glass, and it can replace the cement up to 50% in the mixture and reduce the emissions up to 80%. Granulated blast furnace slag is a byproduct of steel industry, and it can replace up to 30% in the mixture and can divert the emissions from the landfill. Both these alternatives are cheaper, but are currently less available. And let me explain timber through SWOT analysis. Cross-laminated timber is the most common use type. If carefully designed, without compromising the structural integrity and the space quality, if it replaces the concrete, it can reduce the emissions 20 times. But the current weakness with respect to timber is its persistent fire safety misconception. But the opportunity for timber is through New York State Buy Clean and Pension Fund Acts to promote its procurement. The current threat in the market is its limited scale and reliance on imports, which increase the cost. Currently, it procures up to 70% of its requirement from Canada. Now, you can imagine with the tariff rises what's going to happen. Another thing that I would like to emphasize about timber is 2024 New York State Building Code permits mass timber constructions up to 18 plus stories, and the New York City Building Code permits up to 7 stories. When it comes to asphalt, although the conventional asphalt seems to be $3 cheaper than the sustainable alternative, which is the warm mix asphalt, our scenario projections showcase that it will actually be cheaper by 2050. That's because the current asphalt is primarily dependent on the mining and the energy intensive fossil emissions, and they are subjected to the market risk. But our sustainable alternative is made out of recycled content, and it needs lower temperatures and can reduce the emissions up to 36%. Our policy recommendations are across the categories of education and engagement, incentivization, and standards and regulations. Under education, we recommend materials-specific workforce training, R&D partnerships with universities, and Northeast States Coalition for Information Sharing. For incentivization, we promote existing federal and state grants to integrate timber, come up with more tax incentives to promote the sustainable alternatives, and promote public fundings for improved technology across these alternatives. Standards and regulations include supporting the Sustainable Building Materials Act of 2025, establish and renew the EPDs across all the 5 materials. I would like to explain the policy recommendations with examples of steel and glass, which seem to share the same challenges, where making any kind of modifications at the manufacturing stage is very difficult, as it is both capital intensive and time consuming. For example, if it has to change the furnaces, it takes a lot of time. And at the customized product stage, the EPDs are very costly due to as high as $50,000 for glass because of the intensive LCA process. Hence, we recommend that the EPDs can be set at the fabrication stage. For example, for flat glass, it can be 1430 kg CO2e per ton, and for steel, it can be rolled sections at 1163 kg CO2e per ton. With these strategies, we would recommend that the buildings and infrastructure can decarbonize better and sooner. Thank you so much.
Thank you so much for your presentation. I really enjoyed it. I'm interested in the modelling work that you did up to the 2050. If you could talk a little bit more about how, I appreciate you probably talked to the methodology before, but I'd be interested to understand how you built that up and if you did sort of any sensitivity analysis or stuff like that.
That's a great question. So for our 2050 market projections, as I mentioned, we considered the 3 scenarios of shared socioeconomic pathways. And before getting into those scenario projections, we first established the cost drivers for these materials. For example, what is the reason and how much is the percentage of the contribution of these cost drivers of the prices? Like, for example, for steel and for glass, like 70% of the cost drivers are at the manufacturing stage. So we understood how the markets perform at these stages. Like if it is based on the energy, We have come up with assumptions for these scenarios, how the increase of the rate can perform in these scenarios, and based on that, we have come up with the price projections.